The air at 80,000 feet is not a substance familiar to life. It is a frigid, near vacuum, a slate-blue desolation where the temperature lingers at 70 degrees below zero, and the sky above is not blue, but the deep, unforgiving black of space. It is a realm belonging to meteorites and dreams, not to aircraft. Yet, on a morning in the late autumn of 1963, a shape inhabited this impossible space. It was long, lean, and sinister, with wings so vast and thin they seemed like blades meant to cut the fabric of the sky itself. Its skin, a matte, radar-absorbent black, drank the feeble sunlight. This was the Lockheed A-12, Article 123, the most secret aircraft in the world, the precursor to the legendary SR-71 Blackbird. To the few Soviet radar operators who might have glimpsed a fleeting, ghostly return on their most sensitive screens, it was known only as Drozd, the Blackbird. They knew it was there, in a general sense. They knew it flew high, perhaps too high for their surface-to-air missiles. And that was the extent of their knowledge, a knowledge carefully curated by American deception. The Soviets believed they understood the limits of this phantom. They had physicists, good ones, who had calculated the constraints of aerial reconnaissance. At that altitude, the sheer distance, combined with the inevitable haze of the atmosphere, the aerosol soup of moisture, dust, and pollutants that hangs perpetually over the Earth, would reduce any photographic image to a featureless blur. The diffraction limit, a fundamental law of optics, dictated that the resolving power of a lens, no matter how perfect, was ultimately constrained by the wavelength of light and the aperture size. To see a man-sized object from over 20 miles away through that haze was not just difficult, it was, according to the textbooks sitting on desks in Moscow and Cambridge alike, physically impossible. The cameras, they reasoned, must therefore be limited to broad strategic overviews, counting buildings, identifying large installations, mapping missile silo fields. Useful, but not tactically penetrating. The A-12 was a nuisance, a high-altitude peeping Tom, but not a critical threat to their deepest secrets. All of that, the calculations, the assumptions, the smug certainty born of understood physics, was about to be obliterated. Article 123 was not just flying, it was carrying a secret within a secret. Nestled in its chine-lined belly, behind faceted bay doors that sealed with perfect flushness to maintain its radar-eluding shape, was not a standard camera, it was a monster. A technological revolution disguised as a black box. It was returning to its hidden lair at a desolate patch of Nevada known as Groom Lake, not with the expected murky impressions of cloud tops, but with photographic evidence so clear, so shockingly detailed that it would force scientists in CIA laboratories to question their own data. The plane was coming home with pictures that everyone, including the men who built it, had been told were impossible to take. The mission, designated Oxcart 2587, had been born from a persistent, frustrating blank spot on the map of Soviet strategic defense. In the vast arid emptiness of the Sarasagan testing range in Kazakhstan, American signals intelligence had detected the electronic heartbeat of something new. It wasn't a missile test. The signals were too regular, too structured. They hinted at a large, fixed installation, a henhouse or doghouse type of battle management radar, the kind that could guide anti-ballistic missiles to incoming warheads. The strategic implications were profound. If the Soviets were perfecting a functioning ABM system, the delicate balance of terror that underpinned mutually assured destruction could be overturned. But Sarishagan was a fortress guarded by geography and weather. It was over 1,000 miles from any non-Soviet border, buried deep in the continental interior. The cloud cover over the region, especially in autumn and winter, was near perpetual, a rolling sea of gray that frustrated the simpler cameras of the earlier U-2. The mission planners at the CIA's Directorate of Science and Technology, working out of an anonymous building in Washington, knew the odds. They needed visual confirmation, a signature, a footprint, a shadow, anything to validate the electronic whispers. The order was given not with expectation, but with grim necessity. The A-12, the only asset with the speed and altitude to penetrate that deep and survive, would go. The pilot, a man known only by the call sign Dutch 21, received his briefing in a windowless room. The target coordinates were precise. The threat envelope, the known locations of SA-2 guideline missile batteries, was detailed on his maps. The weather forecast, predictably, was abysmal. Layered stratocumulus at 30,000 feet, thickening to overcast below. "You'll be painting on a canvas of soup," his mission commander told him. "The cameras will see cloud, maybe the tops. Consider this a systems verification flight. Get in, get the data, get out. Don't expect miracles." Dutch 21 suited up in his silver pressurized suit, a descendant of the Mercury astronaut gear, and was driven to the shimmering heat haze of the A-12's waiting pad. The aircraft, fueled with a special low-vapor pressure JP-7 that wouldn't boil off in the upper atmosphere, seemed to sweat in the desert cold. He climbed the ladder, settled into the tight cockpit, and sealed the canopy. The twin Pratt & Whitney J58 engines, with their revolutionary turbo ramjet design, spooled up with a sound that was less a roar and more a sustained, earth-shaking scream. He released the brakes, and Article 123 began to roll, gathering speed until the runway became a blur and the nose lifted, pointing toward the slate-gray sky. The climb was a violent, steep ascent into the thinning air. As he passed through the predicted cloud layer, the world vanished into a formless white, then a darkening gray, and then abruptly he burst into the sublime stillness of the stratosphere. Below him stretched an unbroken plain of dazzling white cloud, like Arctic ice under the hard sun. Ahead lay a 4-hour supersonic dash across the Pacific, over the top of the world, and down into the heart of Asia. He was a ghost in a machine, on a mission every expert believed was doomed to return empty-handed. What he, nor the Soviet physicists, nor even the CIA's own conservative estimators knew was that the camera he carried did not play by the old rules. It was about to redefine the possible, bending the laws of optics not by breaking them, but by understanding a secret they had all overlooked. As Dutch 21 crossed the coast of the Kamchatka Peninsula and began the long, tense descent into the airspace over Central Asia, the telemetry flowing back to the control room at Groom Lake painted a picture of futility. The weather data, fed from high-altitude sniffers and last-minute satellite passes, was uncompromising. The cloud deck over Sarashagan wasn't just present, it was a geologic feature. It stretched from 20,000 feet to nearly 40,000 feet, a solid, woolly blanket over 2 miles thick. From his vantage point at 80,000 feet, it looked less like weather and more like a continent of white marble. Then there was the sun. It hung low on the southwestern horizon, a pale, watery disk in the stratospheric haze. For photographic reconnaissance, this was the worst possible scenario. A low sun angle meant long shadows, yes, but it also meant intense, direct glare bouncing off the top of the cloud layer, a phenomenon known as specular reflection. This would flood the camera's optics with scattered light, washing out contrast, bleaching detail, and turning any potential image into a featureless, overexposed smear. The mission planners had hoped for a high sun, which would penetrate the clouds with more diffuse, even light. They got the opposite. The final and insurmountable enemy was the atmosphere itself. Even on a crystal-clear day, the 25 miles of air between the A-12 and the ground acted as a lens of shifting density and temperature. This caused aerial perspective, the same effect that makes distant mountains appear blue and hazy, and mirage, where heat shimmer distorts objects. Over the Kazakh steppe, with its extreme temperature differentials between the cold ground and the various air layers, these distortions were magnified. An object on the ground would not appear as a sharp, distinct shape, but as a quivering, indistinct phantom. The scientific consensus was that resolving details smaller than several feet from this altitude, under these conditions, was a fantasy. In the Groom Lake control room, a somber mood settled. The scientists, men with PhDs in optics and atmospheric physics, watched the real-time weather feeds and the aircraft's trajectory. One of them, a Dr. Arlen from Caltech, pushed his glasses up his nose and made a small, definitive notation on his log sheet. He wrote LPO, low probability of observation. It was a technical euphemism for wasted flight. They had sent a $90 million aircraft on a 4-hour supersonic journey to take pictures of a cloud. But Dutch 21 had an ace in the hole, a piece of hardware so new its own creators spoke of it in hushed, theoretical terms. The camera system in Bay 2 of his aircraft was not the standard CAI Corona Aurelia imager unit. It was the prototype for the Hydra system. Its name was a classified backronym, but its principle was revolutionary. While conventional reconnaissance cameras were essentially gigantic, superbly crafted versions of a studio camera, relying on huge ground glass lenses and vast rolls of film, Hydra was different. It was a hybrid electro-optical system. It used a revolutionary, computer-controlled adaptive optics array, a concept borrowed from astronomers trying to see through atmospheric turbulence to the stars. But Hydra wasn't looking up. It was looking down, through the worst atmospheric soup on Earth. More crucially, it didn't just capture visible light. Its sensors were tuned across a broad spectrum, including the near-infrared. And it didn't just take a picture. It took thousands of micro-measurements of light distortion, heat bloom, and spectral reflection, fed them into an onboard analog computer, a room-sized machine shrunk to the size of a refrigerator, which then calculated and applied a corrective counter-distortion to the lens elements in real time. In theory, it could see through haze and minor cloud by focusing on the specific wavelengths that penetrated best and cancel out atmospheric shimmer. It was a camera that fought the air itself. The system was so experimental, so temperamental, it wasn't slated for operational testing until mid-1964. It had been installed on Article 123 as a field readiness check, a passive test. No one, not even the lead engineer at Lockheed Skunk Works, Kelly Johnson, expected it to work under the conditions Dutch 21 was flying into. It was a box of unproven magic, and the pilot had been told to ignore it if it acted up. A soft mechanical purr resonated through the airframe as Dutch 21 entered the target zone. The Hydra system had auto-activated as per its programming. In the cockpit, a small panel of unfamiliar status lights flickered to life. Dutch 21 glanced at it. He was a pilot, not a camera operator. His job was to fly the line, keep the bird stable, and let the black boxes do their work. He focused on the endless white plain below and the shimmering heat dance of his engine nacelles. Then there was the strange lights. On his panel, a gauge measuring ambient light intensity, a passive sensor meant to monitor general conditions, suddenly spiked, its needle jumping into the red before settling back. He looked out. The cloud tops below him were no longer a uniform brilliant white. They were rippling, not with wind, but with a strange metallic sheen, like oil on water, flashing in patches of iridescent copper and dull silver. It was an optical effect he had never seen in thousands of hours of high-altitude flight. It was as if the clouds had become a liquid mirror, reflecting something that wasn't the sun. Simultaneously, the Hydra system's own dedicated telemetry, encrypted and pulsing back to Nevada, began to send bizarre readings. Its spectral sensors were detecting intense, focused bursts of energy in specific infrared bands, not from the sun, but from discrete points beneath the cloud deck. Its distortion tracking subsystem was going haywire, registering electromagnetic reflections at angles that defied the simple geometry of a cloud layer. The system wasn't malfunctioning, it was detecting anomalies so profound it had no baseline for them. In the cockpit, a caution light illuminated. Amber, not red. Optical system anomaly. Dutch 21 keyed his mic, his voice calm but edged with professional concern. Mother Hen, this is Dutch 21. I'm showing an anomaly on the new optical package. Possible lens malfunction. Getting some wild reflections off the cloud deck. Request instruction. In the Groom Lake control room, the communication was met with a moment of dead silence. The mission controller looked at Dr. Arlen, who was now staring not at the weather screen, but at the raw data from Hydra, scrolling on a green-on-black teletype. The numbers were nonsense. Or rather, they were a language no one had learned to speak yet. Aslan said quietly, his voice cutting through the static-filled silence of the room. It's not a malfunction. He pointed a shaking finger at the data. Look at the IR signature. That's not solar reflection. That's power. Massive, concentrated waste heat. And these distortion readings, it's like it's seeing through a lens made of boiling water. But it's not the atmosphere, it's something in the atmosphere. Something big and hot and wrong. The mission controller leaned into his own microphone, his voice tight. Dutch 21 ignored the anomaly. Continue your run. Record everything. Do not, repeat, do not deviate. The system is collecting data. The order was a lie to protect the secret, but it was also the truth. Hydra was collecting data. It was painting a picture not of a cloud-covered landscape, but of a profound, hidden reality beneath it. The Soviet facility at Sarashagan wasn't just a radar array, a passive eye. The energy signatures, the bizarre atmospheric distortions Hydra was fighting to correct for, suggested something that consumed gargantuan amounts of power and emitted its own intense, structured energy into the sky. The telemetry hinted at thermal plumes like those from a monstrous industrial furnace, and EM distortions consistent with powerful, focused beams. A cold understanding settled over the control room. The scientists had been wrong. The mission wasn't a failure. It had stumbled onto something far bigger and far more terrifying than a new radar. Whatever the Soviets were building under that impenetrable blanket of cloud, it wasn't listening. It was screaming. The landing at Groom Lake was a ballet of controlled urgency. Article 123, its black skin streaked with the peculiar frost patterns of high-altitude flight, glided onto the endless runway as the desert sun dipped below the mountains. Before the engines had fully wind down, a specialized Red Hat security team and a group of technicians in white coats were swarming the aircraft. Their focus was a series of panels along the aircraft's spine and belly. With practiced, gloved hands, they unlocked and extracted several large, cylindrical titanium canisters, each shrouded in insulating material to protect the delicate film inside from thermal shock. The canisters were rushed not to the standard photo lab, but to a vault-like building known as the Dark Room, a facility with a security clearance above top secret. Inside, under the dim, reddish glow of safe lights, the technicians began the development process. The mood was funereal. They had seen the telemetry. They knew about the cloud cover, the low sun, the atmospheric soup. They were preparing to log another batch of atmospheric studies, the agency's euphemism for blank or hopelessly blurred film. The lead technician, a man named Frank, who had processed film from the U-2 shoot-down over Sverdlovsk, threaded the first reel into the developer with a resigned sigh. As the film traveled through the chemical baths, Frank monitored the emerging image on a preview scanner. He expected the familiar gray fog, the faint ghost of a cloud top. What began to materialize on the monitor made him freeze. He leaned closer, his nose almost touching the screen. He blinked, certain it was a chemical defect, a double exposure, some catastrophic error. But it wasn't. The image was sharp, unnaturally sharp. It showed not the top of the clouds, but through them. It was as if a giant invisible knife had sliced a clean wedge out of the atmosphere, revealing the khaki and brown patchwork of the Kazakh steppe below. And on that steppe were structures. Not blurry smudges, but geometric, hard-edged shapes. Long, low buildings, grids of roads, and, most strikingly, a series of 3 large concrete pads arranged in a triangular formation, each with a distinct, complicated superstructure rising from its center. Subsequent frames revealed more. They showed not just visible light images, but layers of data embedded within the emulsion. Thermal differentials were visible as subtle halos around some buildings, indicating massive heat sources, even though the Hydra system's dedicated infrared sensor was a separate and reportedly problematic unit. The geometry of the buildings remained crisp through what should have been multiple, distorting atmospheric layers. It was an image with a depth and clarity that belonged to a reconnaissance aircraft flying at 5,000 feet on a crystal-clear day, not one at 80,000 feet above a solid overcast. Frank called in the scientists. Dr. Arlen and his team crowded around the monitor, their faces illuminated by the ghostly light of the impossible pictures. The room, usually filled with the hum of machines and technical chatter, fell into a stunned silence. One of the junior physicists, a brilliant young recruit from MIT named Chen, finally spoke, his voice barely a whisper. "The Rayleigh scattering, the Mie scattering, this is not possible." He pointed at a building whose roof was clearly discernible, its shadow crisp on the ground. The light from that roof had to pass through 2 miles of cloud ice crystals and water droplets. It should be diffuse, scattered into oblivion. This is like the clouds weren't even there. These photos violate basic radiative transfer laws. But the images were real. They were physical, tangible objects emerging from the chemical baths. They existed. The camera had done what every textbook said was impossible. It had seen through the veil, rendering the atmosphere transparent. The low probability of observation mission had returned with the intelligence coup of the decade, captured on film that, by all rights, should have been blank.